Let's talk about concurrency, the ability of a system or program to handle multiple tasks simultaneously, which is one of the essential aspects of modern computing. The Wikipedia definition of concurrency says concurrency is the ability of different parts or units of a program, algorithm, or problem to be executed out of order or in partial order without affecting the outcome. This allows for parallel execution of the concurrent units, which can significantly improve overall speed of the execution in multiprocessor and multi-core systems. And then it also says that in more technical terms, concurrency refers to the decomposability of a program, algorithm, or problem into order independent or partially ordered components or units of computation. So, in some simple word, it means concurrency enables multiple processes or threads to run in parallel, improving the overall performance and responsiveness of the system. Without concurrency, a program can only execute one task at a time. This can lead to slow performance and unresponsive user interfaces. The second part of Wikipedia definition is basically referring to the design aspect of concurrent system. So, in the context of system design and development, we can say the concurrency is a decoupling strategy. It decouples what from when. And this decoupling of what from when part can dramatically improve both the throughput and the structures of an application. But structure is not the only concern behind adopting concurrency. In some cases, and now we can say in most of the cases, systems response time and throughput are the key constraints too. Consider a system that take 1 second of time per user request. In normal days, it can be called a highly responsive system for a few users. But what if the number of users increases? Let's say now it is scale up to 500 users. If it is a single threaded system, one will have to wait for 500 seconds to get its request resolved. So, how can we improve the response time of such a system? The answer is by handling many users concurrently. Now, the question comes, how do we achieve that in our program? So, concurrency can be achieved in various ways, such as through multi-threading, multiprocessing, and asynchronous programming. These are the three popular approaches of building concurrency in a system. Let's understand these concepts one by one. In basic terms, multi-threading is the ability of a processor to execute multiple threads concurrently, as supported by the operating system. In a multi-threaded environment, each thread runs in parallel with every other thread, and they share the same memory space with the main program. Think about a normal word processor. It spells check each and every word that you type while you're still typing it and highlights the spelling and grammar issues instantly. If this process would have been single threaded, would you be happy with the response time of your word processor? Certainly not. So, your MS Word application, your window, these are the multi-threaded applications that we use in our daily life. In one line, we can say multi-threading allows access to two or more threads. Execution occurs in more than one thread of control using parallel or concurrent processing. Now, what is multiprocessing then? Multiprocessing, as the name suggests, is the ability of a system to run multiple processors simultaneously, where each processor can run one or more threads. It is like using two or more CPUs within a single computer system, where operating system allocates tasks to the available processors which work on them simultaneously. So nowadays we use multi-core processor based operating system and we already know the differences in their performance. And now finally, what is asynchronous programming? The asynchronous programming basically allows a program to continue executing other tasks while it is waiting for a specific task to complete. That's why it is asynchronous. In a nutshell, concurrency is an important aspect of software development, but it has its own set of challenges, such as managing shared resources, dealing with the race conditions. So it is important to design the concurrent system very carefully. And that's why we generally say in the programming world that designing concurrent system is hard. So what kind of challenges do we face while designing the concurrent systems? And how concurrency can be implemented in Java? We will cover those kind of aspects in the later parts.